are implicitly related by so let's say x squared plus 3y squared plus xy equals 10. All right, I want you to find dy dx for all points on this curve. Does anyone happen to know what kind of curve this is? You don't have to know, but so this is actually an ellipse, but it doesn't matter. It's a tilted ellipse. Okay, so I'm going to give you a few minutes to work on this. So try to mimic what we did in the previous example, right? We have an equation that involves x and y. How do I find dy dx? I differentiate both sides, and then I solve for dy dx, right? It sounds simple. It is in in theory. In practice, the derivative might give you a little bit of trouble, and the algebra might be a little bit annoying. But in theory, it's just 2 steps, right? Differentiate both sides, solve for dy dx. Now, just remember that you have to use chain rule. Anything that has a y on it, those y's are really f of x's. So you have to use chain rule. I'm going to give you 2.5 minutes to do as much as you can. All right, so let's look at this. Okay, so obviously we use implicit differentiation. And I'm going to start emphasizing we're using this with respect to x, right? Because if you want dy dx, that means treat x as the independent variable and differentiate with respect to x. I can also talk about dx dy, where I think of x as kind kind of the function, like if taking place of the dependent variable and y is the independent variable. That's different. We might do an example like that. But for now, we'll just do with respect to x. Okay, so let's rewrite this equation, right? Because this is the equation we are going to be differentiating. Now on the next line, let's actually write down the derivative of both sides. So who wants to start us out? So I'll start you out. 2x. There you go. No one's getting off free for that one. Who wants to do the next term? 3y squared. Caleb, you want to tell us what the derivative of 3y squared is, don't you?
I put 6 f of x times the derivative of f of x.
Okay, 6 f of x times the derivative of f of x. Right, but we're no longer going to be writing it like that. Now, so right now, as you're getting used to it, I do suggest you might want to keep on reminding yourself that y is a function of x, right? Think of this as y is a function of x. But like what Kevin wrote in the chat, we're going to actually get used to just writing this as 6y times dy dx. Okay, now who's going to do the next term for us? Oh, I was going to call on Adam, but he's not actually here. And now that's on tape for everyone to know forever. Tape on tape on Zoom. You know what I mean? So we'll have to tease him in Discord later. Who's talking
Dr. G, can I give it a try?
Simran's like, excuse me.
No, I'm so sorry. I'm so sorry.
No. Go ahead, Simran.
So basically I put x times f of x, and in that case you would use chain rule. And so using chain rule, you would get like x times f of x to the power of 0 times f1 of x, or f prime of x, or times f prime of x.
Okay, so say it again. So start over. So say it again.
So it's x times f of x to the power of 0 times f1 of x.
Times f1 of times f prime.
F prime, yeah.
Okay. So you're saying it's x times f prime of x.
Yeah. So then you would do x times dy over dx.
Okay.
Sorry, I'm making like a race 20 times.
It's okay. So we have x dy dx. So Syed says, huh? Jacqueline says, I got that too. I did that. What's going on? Caleb says, so product rule is wrong. Well, what do you think? Is the last term just dy dx because both x and y are 1? Well, actually, it's a good question. So let's erase that for a moment. So what other terms do we have here? So we have x dy dx. What other things do people think? Ayana said x dy dx plus y. Did we have any other thoughts about what the derivative of just xy? Just the derivative of xy. What are the f of x is? Well, we'll talk about this in a second.
I agree with the second one.
The x dy dx. Why do you agree with the second one, Thomas?
Because you're using the chain rule. You're doing you're taking x plus dy dx, and then you're doing y prime after that.
Yeah, but how did you get this plus y? Where is that coming from?
That's coming from the product rule.
Product rule. Okay, right. Yeah, it's product rule. So we're using product rule and chain rule. I mean, chain rule, it's up to you whether you want to think about using chain rule. It's just y, and the derivative of y is just dy dx. But you can also think of it as chain rule as it's 1 y to the 0 times dy dx. But the big thing I want everyone to realize is you have to use product rule. Okay, that's the big thing. So if you missed product rule, that's a mistake. So let's actually write that down. Product rule. Disregard your statement. You forgot product rule. I disregard everything. It doesn't matter. That's okay if we make mistakes. So product rule. So thinking of this, remember, what is the stencil for product rule, right? Just so everyone sees this. Right, f prime g plus fg prime. So in this case, what is f? So let me kind of write this. I'm saying that x is f and y is g. And then I'm going to use product rule. And let me erase this because I don't want that to be confusing. Okay, so f prime in this case would be 1 G is just y, and then f is x, and g prime is dy dx, right? So it's exactly product rule, right? It's not 1 times 1, right? It's not x times dy dx or anything like that. Remember, y is itself a function of x in disguise. That letter y is kind of taking the place of a big long formula in terms of x. So you have to treat it using product rule. Okay. All right, now we solve for dy dx. And like I said, solving for dy dx will always be possible because the algebraic structure of this equation, it's linear. Look at how dy dx appears. It only appears to a first power with stuff multiplying it. It doesn't appear to dy dx squared. Like product rule never tells you, oh, multiply by the derivative squared. Chain rule never tells you, oh, divide by the derivative, right? It doesn't tell you things like that. Dy dx will only ever appear to the first power. So what does this equation actually look like? If dy dx is your variable, so let's call that, let's just keep as dy dx, whatever. Everything else is basically a coefficient. So this looks like a plus b dy dx plus c plus d dy dx, right? Where a, b, c, and d are just, they're just coefficients. I mean, they depend on x and y, but who cares? They're just coefficients. So how would you solve this equation regularly? You get all the dy dx's to one side, all the non-dy dx's to the other side, divide and solve. That's it. Okay, so let's do that. So all the dy dx's will stay on the left side, and all the non-dy dx terms will go to the right side. So negative 2x minus y. Now I factor out the dy dx. We all know how to do this. And I divide by that coefficient. So dy dx equals negative 2x minus y all over 6y plus x. That's it. All done. Right? So keep in mind that this was just algebra. No calculus. Those last few steps. Do you care if you use y prime instead of dy dx? Well, the problem with the prime notation is you have to be very careful because sometimes it's ambiguous which variable you're going to be differentiating with respect to. Maybe for now, you can use y prime because it's obvious that you're using x as the independent variable. But once we get to related rates, we're going to have other variables other than x involved. So it's probably not good to use prime. So I would very strongly suggest whenever you're dealing with implicit functions, do not use prime. Use the Leibniz notation, dy dx. So there's no ambiguity with which